All right, this is the Math Models, Unit 1, Lesson 7 video over properties of addition and multiplication. I've shared a file with you on the classroom page called Number Properties in Simple Language. And what I've done is I've taken these properties that they present to you in mathematical terms, like you see down here, commutative property, A plus B equals B plus A, or A times B. All of these are given in sort of formulas. So I've kind of boiled them down into it's kind of like more like more descriptive language, so you can understand the kind of concept as opposed to just memorizing a formula. So we're going to go through these, and then we're going to look at the way the lesson presents it. So all of these are properties that apply to when you're doing addition and multiplication of numbers. So we'll talk through them piece by piece. So the commutative property. The commutative property says, and let's jump over to my little description here. Let's find it. Let's see. Commutative property says that basically numbers being added together can be ordered in any way. In other words, if I were to add a new note here. Oop. A plus B plus C, it's the same as B plus C plus A, or A plus C plus B, or B plus A. You can see I'm making up every combination here. All of these equal the same thing. The same thing is true of multiplication, just to kind of drive this point home. A times B times C is the same as B times C times A, is the same as this, is the same as this. So the commutative property tells us that doesn't matter what order you multiply numbers or what order you add numbers, as long as it's all addition or all multiplication, you get the same answer. All right, that's the commutative property. The associative property is a similar concept, but this time we're talking about grouping. So this means that when I'm multiplying, for instance, if I were to put parentheses around these numbers, or around these numbers, the answers would still be the same. Okay, these are still going to be equivalent things. So these are combinable. So in other words, I can rearrange and group numbers differently as long as it's all multiplication or all division. That's still true. So the associative property is all about the grouping of numbers. So again, just to drive the point home for the addition side, I can add numbers like this. And again, those two expressions would be equal, even though I've grouped A and B on this one and B and C on the bottom one. So there is no difference to the answer because of the properties that addition and multiplication have. So associative property is all about grouping. And I've written that here. Associative property, numbers that are being added can be grouped any way. Associative property of multiplication, numbers that are being multiplied can be grouped any way. All right, let's talk about the distributive property. The distributive property says that when I have, erase all this, when I have numbers that are being multiplied, let's do real numbers this time, by numbers inside parentheses, doing it this way, 2 plus 5 is 7, 3 times 7 is 21, gives me the same answer as doing it this way, 3 times 2 plus 3 times 5, which is what the distributive property is. The distributive property says we can multiply 3 times both numbers in that parentheses, and we get the same answer. We can see that that's true. 6 plus 15 is 21. So we get the same answer. So the distributive property says that I can multiply the number in the front times each number inside the parentheses to get the answer. That's what it says for here if you look. Distributive property. When a number is being multiplied by numbers inside parentheses, you can multiply each number separately, which is what I did here. 3 times 2, 3 times 5, or I can add what's inside and multiply. Typically, this is going to be dealing with algebraic things, so there'll be an x in there maybe, and so that's why this is useful for that kind of stuff. Identity property. I'm not going to say too much about this, but just simply put, if you add 0 to a number, it is that number. It doesn't change the value. Similarly, if you multiply times 1, that number stays the same. That is what identity properties do. They say a number times 1 is itself. A number plus 0 is itself. So that does not change the value. Then we have inverse property. Inverse property says that if I add the negative, or in other words, subtract the same number from itself, it becomes 0. A number minus itself is 0. Multiplication inverse. A number divided by itself is 1. So you notice addition deals with zeros. Multiplication deals with ones. So multiplication inverse says that if I divide, or in this case, multiply times a fraction over that number, but this is the same thing as saying divided. If I divide a number times itself, I get a 1. And then lastly, multiplication property of 0 just says that if I multiply a number times 0, the answer is 0. And in fact, that's the only way to multiply to make 0 is to multiply by a 0. All right, so those are the properties. And the way that the lesson proceeds is you have to match examples with the correct property. So I'm going to walk through a few of these, but I want to leave a lot of these for you to do because I really want you to understand the concepts. So let's talk about this problem, right? So we're gonna look at this. It says name the property illustrated. We have x times 2 equals 2 times x. So let's look through the options and let's make some eliminations. I think it's pretty easy to eliminate some options. So the identity property. Going back, we see the identity property is either that a number times 1 is itself or a number plus 0 is itself. Well, it should be pretty clear to you that neither of those situations are happening here. We have multiply times 2, not by 1, and we don't have adding 0. So it cannot be the identity property. Inverse property is similar. Inverse property talks about either subtracting a number minus itself or multiplying or dividing a number by itself. So it can't be the inverse property. Again, I'm just using this basic idea of understanding what am I looking for? If I was looking for inverse, I would expect to see something about a number divided by itself or a number minus itself. We don't have that here. Associative property. Associative property deals with different groupings. Numbers being grouped differently. These numbers are not grouped differently. They're grouped by themselves, each in their own little thing. So that's not going to be the answer. Then we have the commutative property. The commutative property says that numbers are being added can be ordered any way, or multiply can be ordered any way. So the order of the numbers changes. And I think it's pretty clear that is what we have here. X times 2, 2 times x. The numbers have been switched where they are located in the expression. And it's clearly not the distributive property because we do not have a number being multiplied by a group of numbers, which is what we need to see if we were looking at distributive property. So I've just kind of walked you through the process you need to do each time. So you need to be looking at the options, and it looks like they give you the same 5 options each time. So you just need to find which one matches. So for instance, let's just look at number 6. 1 times y equals y. Okay, I see a number times 1 equals itself. And I look down here, a number times 1 is itself. I think that is going to be our answer, and that was the multiplication identity. So we go back and identity property. That's all you got to do. So you need to just use those descriptions of those properties to decide what's happening here when I do this particular thing, the specific example of those properties. Okay. Then They want us to actually do that property. Okay, so we're going to walk through a couple of these, and then we'll talk about kind of what else you need to know on this. So, for instance, now we're applying a property. It's like this one. Complete the statement. 7 plus xy equals blank. So we have to fill in the blank, and we have to use the commutative property of addition. Okay, so let's go read that. The commutative property of addition, sorry about that, says that numbers that are being added can be ordered any way. So we need to change the order of the numbers as they are being added. So if we start with 7 plus xy, then clearly what needs to happen is I need to switch places. I should be looking for xy plus 7. And sure enough, that's one of our answer choices. And this is really it. You just need to figure out what matches the pattern of this type of property. I would say that there is some value in the examples as they give them up here. You might want to look through maybe these because the answers down below, or the questions down below, are going to follow these patterns. But in general, you need to just have an understanding of how the properties work. So for instance, if I want to take a number 12, if I want to take this and apply the distributive property, then I need to end up with something where there is a number being multiplied by a group of numbers, or by numbers in parentheses. Well, I don't have that here. I don't have that here. So it's got to be one of these three. After that, it's a matter of you deciding which one actually gets me the answer. So if I do 2 times x squared, I get x squared. If I do 2 times 6x, I get 12x. And if I do 2 times 9, I get 18. So actually, that's my answer. So once you eliminate the ones that don't even match the pattern, you need to check each of these to see if you can get the correct result. That's just one example. So all of these, you're going to be applying the property to make it fit the pattern of what that property is. Number 16. Use the distributive property. Well, I need to multiply this number times these numbers. I need to do -2 times 5x, and then I need to do -2 times 3. Work it out. -2 times 5 is -10x minus -2 times 3. Notice there's two negatives here, so this is going to end up being positive 6. And sure enough, we have an answer right there. So I haven't done all of these for you, but I've done quite a few. I think that you can handle doing the rest of them. There are quite a few problems down here. Don't let the negatives throw you off. You're still going to do the same exact process. You need to figure out in this one. Actually, let's just do this one together. So I need to figure out which one of these leads to this up here, right? So which one of these is going to use the distributive property to get that up there? Well, a couple of things to note. I see here if I have x and x squared, that's going to make x to the third. That is not here or here, so that cannot be the answer. That also is going to rule out, well, no, actually that should be fine for the rest of these. So that gets us at least one of those eliminated. Now I need to figure out, let's do this. 2/3 times 5. 2/3 times 5. Let's go to Desmos and see what 2/3 times 5 is. 2/3 times 5. Oops. I'm actually going to jump over to the there you go, scientific calculator. 2/3 times 5. I can turn this into a fraction by pressing right there. 10/3. That's also 2, or no, it's 3 1/3. but 10/3 is what we get. None of that is not correct because this is not 10/3, it's 5/3. That cannot be the answer. And so I just go from there. I need to again confirm 5/3 times, okay, that works, but then 5/3 times 2 is also going to be 10/3. That is not what's there. That's incorrect. 1/3 times 5, that gives me 5/3. 1/3 times 2, that gives me 2/3. Problem is there's no x in the second term. So it has to be the last answer choice. And so that's really it. I know there are a lot of problems in this lesson, so please do your best. If you want to reach out to me after you've made an attempt, we can go over the other distributive property ones together, and I'm happy to work those out. So please let me know, because if there's a lot of requests for that, I will make a separate video where I go through all the distributive property questions in this lesson.